Guys, today we are on page 27 in your Unit 1A notes packet, and we're going to take a look at factoring three-term polynomials or trinomials. So when we're looking at factoring trinomials, there are two different strategies I'm going to show you here. One of them should be familiar from Algebra 1. It's what we're going to call sort of a guess and check method. And then the other one we're going to call the AC method. So the AC method, which will be our sort of new strategy for today, is a way to factor three-term polynomials, but treat them like they're four-term polynomials. So we can use our grouping method that we talked about on page 26. So here's the big idea behind the AC method. What we're going to do, here's why it's called the AC method, is we're going to take our A and our C and multiply them together. Remember, when we have a polynomial that's a quadratic, degree 2, in standard form, that lead coefficient we can refer to as A, and that constant term often gets called C. So that's why it's called the AC method, because we start by multiplying A and C. And then to determine how to split up our middle term, we're going to take factors of A times C and find those factors that add to B, that add to our middle term. So we want factors of 6 that add to 7. Well, that would be 1 and 6. Those would multiply to give me 6, but if I add, they give me 7. So we're going to rewrite this trinomial as a polynomial with four terms by splitting up our middle term. So instead of 7x, we're going to use 1x and 6x, those factors that add to the middle term that we've just chosen here. So now I have a four-term polynomial, and we can factor this by grouping. So I've got one group here at the front, one group here at the back, and then we're going to factor this the same way we factored our four-term polynomials on page 26. So we'll look for the GCF of each group. For this first group, our GCF is x. That would leave me with 2x plus 1. For the second group, my GCF would be positive 3. That would leave me with 2x plus 1. Now that stuff in parentheses is the same, so that's my GCF for the entire polynomial. And when I pull that out, I'm left with x plus 3. Is what we have here. So that is another strategy we can use to factor these trinomials. As I go through our practice problems today on page 27, I'm going to show you that guess and check method that we use in Algebra 1. I'm also going to show you AC method. So if you struggled a little bit in Algebra 1 with that guess and check strategy, particularly when we have a lead coefficient that's not 1, maybe try the AC method. So let's take a look at our first problem here. Just like we talked about on page 26, the first thing I want to do anytime I'm factoring any polynomial, no matter how many terms it has, I want to start by looking for a GCF. For our first example, we have a GCF of 2. So I'm going to start by factoring out that GCF of 2. So that would leave me with x squared plus 3x minus 10. And now for our Algebra 1 strategy, or sort of what we're going to call guess and check strategy, we would be looking for factors of negative 10 that add to 3. Since our lead coefficient here is just 1, I don't need to worry about any factor in front of here impacting my distribution later on. So this would just be factors of negative 10 that add to negative 3. If you need to make a list, make a list. So factors of negative 10 would be negative 1 times 10, or 1 times negative 10, negative 2 times 5, or 2 times negative 5. So to get to positive 3, I want to use negative 2 and 5. So this would be x minus 2 times x plus 5. Don't forget your GCF of 2 in front. And that would be our factored form. We can also approach this using the AC method. So our A this time is 1, and our C is negative 10. So we're still going to be looking for factors of negative 10 that add to 3. Now we know that that's going to be negative 2 and 5. So if I'm using AC method here, I'm actually going to rewrite this as x squared minus 2x plus 5x minus 10. The order on these is not important. You can correctly factor even if these two middle terms were swapped. Keep the first term at the front, keep your constant term at the end, but your middle two terms here that we split up can be in any order. Now I'm going to split this up into two groups to use my grouping method. Since it's 4 terms, I use grouping. My GCF from the first group would be x. That would leave me with x minus 2. My GCF from the second group would be positive 5. That leaves me with x minus 2. My stuff in parentheses is the same. So that's my new GCF that I'll pull out. That leaves me with x plus 5. And again, don't forget the GCF that we pulled out in front to begin with. So here's that guess and check method. Here's our AC method. For this particular problem, after we pulled out our GCF, our lead coefficient was 1. So our AC is going to have us look for factors of the same number as our guess and check strategy. Guess and check, maybe a little bit faster on this one. Let's take a look at our next example, 2x squared plus 7x plus 3. Now, there's no GCF here, so I'm stuck with the 2 in front of x squared. That means when I go to use my guess and check method, I'm going to have a factor that starts with 2x and a factor that starts with x. Since 2 is prime, I know it's got to be at the front of one of these. There's no way for me to break it up. Then what I'm going to look for are factors of 3, which would just be 1 and 3, or -1 and -3. Factors of 3 that I have to place within these factors so that when I distribute, I get 7. Since I want positive 7, I'm going to go ahead and eliminate the negative factors from this list. So it's going to be +1 and +3, or +3 and +1. I'm going to try +1 and +3 to start, and then I'll check with distribution. So that would be 2x squared plus 6x plus 1x plus 3. If I combine those middle terms, I would get 7x. So this would be my factored form. If I hadn't got 7x in the middle, I would swap the 1 and 3 and try again. For AC method, what we're going to do here is start by multiplying the A and the C. So 2 times 3, that gives me 6. Now I want factors of 6 that add to 7. Well, that would be 1 and 6. Now I'm going to rewrite this, keep that first term the same, by splitting up the middle term using the factors I've chosen. So plus 1x plus 6x, and then keep that constant term at the end the same. Now I've rewritten this in 4 terms. So I'm going to split this up and use grouping. My GCF here would be x. I'm left with 2x plus 1. My GCF here is 3, positive 3. So I'm left with 2x plus 1. My stuff in parentheses is the same. So I get 2x plus 1 times x plus 3. So for our guess and check strategy on this problem, I guessed correctly with the 1 and the 3 the first time. So I still needed to double check my work. But if I hadn't guessed correctly, I would need to then swap these numbers and check my work again. So depending on how lucky or how strategic you are with guess and check, you might get that factoring on the first try. For AC method, the nice thing is that it doesn't matter what order I put those middle terms in, as long as I multiply A by C and find those correct factors that add to the middle term, I'm going to come up with that correct factorization and not have to retry a different factorization. Let's take a look at another example here. For our third problem, again, we have a GCF here. We have a GCF of 3. So I'm going to go ahead and factor that out. So we've got x to the 4th plus 5x squared plus 4. Now, since my lead coefficient is 1, this is an example, kind of like our first example, where guess and check is probably a nice, quick, easy strategy. So I want factors of 4 that add to 5. That would be factors of 4 that add to 5, 1 and 4. So I would have x squared plus 1 times x squared plus 4. I'm using x squared here because I need to get x to the 4th. So when I distribute, x squared times x squared gives me x to the 4th. And I know my middle terms need to have x squared. So when I distribute, x squared times 4 and 1 times x squared will give me that x squared term in the middle. Now, for right now, we can't factor these down anymore. So we're just going to leave that here. Don't forget to bring your GCF in front. If I did the same problem with AC method, remember we pull out our GCF first. So my A is 1. 1 times 4 gives me 4. And now I want factors of 4 that add to 5, which would be 1 times 4. So for AC, we would rewrite this as x to the 4th plus 1x squared plus 4x squared plus 4. And again, if you swap the order on these middle terms, that's fine. Now, since I have 4 terms, I'm going to use grouping. So groups of 2 here at the front, my GCF would be x squared. That would leave me with x squared plus 1. For my second group here, my GCF would be positive 4. That would leave me with x squared plus 1. 4 divided by 4 is 1. Now, x squared plus 1 is my common factor, and x squared plus 4 is what's left. And then again, don't forget our GCF of 3 in front there. So again, since we pulled out a GCF and my lead coefficient was 1, guess and check a little bit faster than AC method. For our next example, again, we do not have a GCF. So I've got a lead coefficient here that's not 1, which means for my guess and check strategy, just like the example right above, I'm going to have to try something and check it, and I may have to then retry a different factorization. So we're going to start again with AC method, or with, sorry, guess and check method. So since 3 is prime, I know one of my factors will start with 3x, and the other factor will start with just x or 1x. And now I want factors of 10. So factors of 10 could be 1 times 10, or -1 times -10, could be 2 times 5, or -2 times -5. So we've got a little bit longer list here than we had with our second example. So that means I've got more options to try and check. Now I want negative for my middle term, so that tells me I'm probably going to want some negative factors here. So I'm going to get rid of the positive options. And I'm going to try -2 and -5. So let me try a placement here. We'll go -5 and -2. And then I'm going to distribute. So this would be 3x squared minus 6x minus 5x plus 10. When I combine like terms in the middle, I get -11x. So this is not the option I want. So I'm going to switch the -2 and -5. So this was not right. I'm going to try a different factorization. Again, I'm going to check by distributing. So that would be 3x squared minus 15x minus 2x plus 10. This time we get -17x in the middle. So this is my correct factorization here. I tried something and it didn't work. So I swapped those numbers in my factors and tried again. Now, if this hadn't worked, I would try -1 and -10 in my factors. Let's try the same problem with AC method now. So for AC method, I'm going to take A and C and multiply them together. So that would be 3 times 10. That gives me 30. And now I want factors of 30 that add to -17. So if those factors don't jump out at you, make a list. And I always suggest you start with 1. So 1 times 30, or -1 times -30, 2 times 15, or -2 times -15. And those are the ones that I want. That would add to -17. I always, if I need to make a list, go in order. That way I don't accidentally skip the factor that I'm going to need. So I'm going to need -2 and -15. So I'm going to replace that middle term by splitting it up using the factors I've chosen. So this would be 3x squared minus 2x minus 15x plus 10. Now that I have 4 terms, I'm going to use grouping here. In my first group, I have a GCF of x. That leaves me with 3x minus 2. In my second group, I would have a GCF of 5. And since this term at the front of my group is negative, I'm going to take out a -5. I like the terms in the front of my parenthesis group to be positive. So this would be positive 3x minus 2. And since I factored out a -5 here, my step in parentheses is the same. So I get 3x minus 2 times x minus 5. And there's my factored form. same as what we got here, but with our guess and check method, again, if you misplace your terms at the end of your factors, swap them, try again, try different factors. I like AC for problems like this where we've got a lead coefficient that's not 1, because I won't ever have to retry my factors. I know using that AC method, I'm going to get a correct factorization the first time through. Our last problem here, again, has a lead coefficient of 1, no GCF. So if I start off with my guess and check method, I'm going to look for factors of -48 that add to -2. Now, 48, got a lot of factor options here, so I'm going to start by making a list. So this would be -1 times 48, 1 times -48, 2 times, or -2, I should say, times 24, 2 times -24, divisible by 3, -3 times, that would be 16, or 3 times -16, none of these adding to -2 yet, -4 times 12, or 4 times -12, not divisible by 5, 48 is divisible by 6, so -6 times 8, or 6 times -8, and that's the one I need. That will add to -2. So my factorization here would be x plus 6 times x minus 8. If I use that AC strategy, we would take 1, since that's our A, times -48, and I would be looking, which would be -48, and I would be looking for factors of -48 that add to -2. So we've done that work already. We know that it's 6 times -8. Now for AC method, I would rewrite this with the middle term split up using the factors we've chosen. So this would be x squared plus 6x minus 8x minus 48. And again, the order on these middle terms is not important. If you have them swapped, that's fine. Now I split this up into groups since I have 4 terms. The GCF for our first group is x. That would leave us with x plus 6. The GCF for our second group would be 8. Again, since my group starts with a negative number, I'm going to pull out a negative GCF. So -8 for my GCF, that would leave me with x plus 6. Now my part in parentheses here, that x plus 6 is the same, and that's my common factor for the entire problem. And when I factor that out, that leaves me with x minus 8. So same factorization. Okay, so that's factoring trinomials. For some problems, as we've seen, guess and check method is pretty quick and simple. For other problems, we might want to consider that AC method. So that's, again, factoring trinomials using the guess and check method and the AC method.